In other words, we are going to look at norms of a specific vector space. This is a vector space of matrices. Okay, so let I'll take A to be an n cross n matrix. Okay, any matrix. Now, what is the norm of this? How do you find the norm? Well, set of all n cross n matrices form a vector space. Therefore, there's an inner product. What is the inner product? Trace of A Hermitian B, right? That is your inner product. That will induce a norm called what? What is the norm induced by trace? I think you should remember certain names. Okay, unfortunately, it's called Frobenius norm, right? It induces a essentially you square every element. Square meaning since it's complex, you have to take the absolute square and then add them and take square root, right? It's a norm. Now, are there any other norms? Again, let's use the doctor's analogy, right? What is the doctor's analogy? I don't know how to find the norm of a new object, but I know how to find the norm of a vector, right? How do you convert A into a vector? One way is you stack one below the other and form a long vector. But the other way is I'll take a vector and operate A. I'll get another vector, right? So AX is a vector. Do you agree? Right? I'll take the norm of that. I know how to take the norm of that. For example, I'll take 2 now, right? Right. So if I change X, I'll get different norms, different values, right? I can take that as my measure of size of A or norm of A, right? Maybe I can take supremum over all X. What is the issue with this? What is the issue? I take X equal to some 100,000 times 1,0,0,0,0. Then it will blow up, right? And then your friend will say, I'll take 1 billion power 1 billion. Then it will be more. Eventually it is infinity, right? You can prove that it's infinity. You give me any number as this norm, but then I can get another vector which is more than that. So now what is the fix? I should not allow any X, right? I should restrict my X also. So in other words, I'll take X on the unit circle. Okay, so this is unit circle. I'll take an X on this unit circle and see what A will do on that. In particularly, whether it will amplify or what is it that it will do. So how do I do that? I can just divide it by norm of X. See, I can push norm of X inside the numerator norm, right? So AX by norm of X. So this, for example, here is a unit vector, right? I'm just taking a unit vector, operating A and seeing the size of that unit, that vector. So that will tell me what is the size or the power of A, right? So this is called, there is a name for it. It's called the operator norm of A. Okay. Well, maybe I should not say induced. I'll say operator norm. Right? Is that clear? Okay, right? Now, of course, the moment I say operator norm, the moment I say norm, you should satisfy certain properties, right? Intuition. What are the properties? First of all, it should be positive. Is it positive? Obviously, right? It's a norm ratio of 2 positive numbers and taking the max of that or sup of that. So it has to be positive. So clearly, I'll not prove this, or you should be very careful. I mean, in math, especially when you say clearly, right? So many times it's not clearly. Greater than or equal to 0. Equal to 0 if and only if. Why is this true? Suppose it is 0, right? That means you take the supremum of X, that is 0. If supremum of X is 0, then every X should also be 0, right? This ratio should be 0 for every X. If it's 0 for every X, then I can take X to be 1, 0, 0, 0. What will 1, 0, 0 do? It will select the first column of A. You are saying the first column of A is 0. Second column of A is 0. Third column of A is 0, and so on. Every, if you know, sorry, what am I saying? Every, A is 0, right? A should be 0, right? So that means it satisfies at least one property of your norm. What is the other property? Norm of alpha times A, right? Well, this is easy because I can pull alpha out of the numerator and out of the supremum also, because supremum is with respect to x. This is clearly norm of. This is also fine. So size of the scaled vector is the scaling times the size of the vector, right? So that's what we have. So what about triangular inequality? Let A B belongs to C n cross n. Then I'll look at A plus B operator norm. This requires some thinking. Let's see if it is true, right? So how do you prove this? This is called what? This is called what? Triangular inequality, right? So how do you prove this? So let's look at this. Okay, so A plus B operator norm is basically supremum over all x, Ax plus Bx, right? 2 norm divided by norm of x. A plus B times x is Ax plus Bx. Okay. Now, what can you say about 2 norm? It's a norm, right? It should satisfy triangular inequality. So by triangular inequality, I can write this, right? Fine. This is also easy. Okay, what next? If I can split the soup, right, then I'm done, right? So supremum of f of x plus g of x. Okay, so let's see. Supremum over all x, f of x plus g of x. What can you say about this? If I split the supremum, see, you have a function, you are looking at the maxima. You have another function, you are looking at the maxima. You are adding those maxima. That is like soup g of x plus soup f of x. Will be like very high, right? Compared to when you look at the sum of these two functions, it could be something like this, which is like the maxima could be very small, right? So supremum overall this is less than or equal to, I think intuitively this is clear, right? G of x. So I'm going to use this x norm of ax divided by norm of x. F of x here is norm of ax divided by norm of x. G of x is norm of bx divided by norm of x. Okay. Now that means the operator norm is a norm actually, right? So now the next question that we should ask is, did I anywhere use the fact that A is a square matrix? No, right? I can do this, right? So I can do m cross n, right? So I can take any matrix. So I'll take 2 m cross n matrix. Of course, yeah. Okay, so that means you have an operator now. Suppose A belongs to, okay, let's look at this. Suppose A belongs to